Hello and welcome to today's share webinar with Luminex, Confluent, and Hitachi Vantara, building mainframe data pipelines to feed enterprise-wide applications. My name is Julianne Kennedy, and on behalf of Share Headquarters, I would like to thank you for joining us today. Share is pleased to continue our webinar programming with this informative and educational event. Today's presenters are Art Tolsma, CEO of Luminex, Jeff Bean, Partner Solutions Architect at Confluent, and Derek Wilson, Digital Solutions Engineer at Hitachi Vantara. I'd now like to go ahead and turn it over to Art. Please go ahead.
Thanks, Julianne. This is Art Tolsma, and I'm excited to lead off this presentation today, followed by Jeff Bean of Confluent and Derek Wilson of Pentaho, with Daniel Saunders of Luminex providing an active demonstration of how what we talk about today actually works in real life. So before diving into the content, I want to quickly highlight the nice logo in the title page that you'll see again later. It's a nice picture of a mainframe with "Do More" across the front and icon representations of modern enterprise applications and platforms. This presentation is intended certainly for those who have a mainframe in their organization, but more specifically for those that recognize their mainframe as strategic and want to do more to leverage the platform and its data throughout the organization. So jumping into the agenda and flow of the discussion today a little bit, I'm going to spend a few minutes talking about some of the unique challenges of integrating mainframe data sources and into the broader IT environments. Mainframes remain central and core to IT, but there has been a dramatic and dynamic transformation in enterprise IT over the past several years, not just with enterprise public computing as a public cloud computing as an operating model, but the agility, flexibility, and cloud-native approaches that are now part of on-premise and hybrid multi-cloud IT. The expectations and requirements to have the right data in the right place at the right time for the right applications and platforms have simply increased. And this has created the opportunity for the mainframe to no longer be an independent silo of applications and data in the data center, but to play an integrated role within enterprise IT. Following me will be Jeff talking about the transformational technologies of Kafka, and Derek will talk about the modern data processing and workflow capabilities of Pentaho as an example of application endpoints. Daniel will provide a brief demo of how this all works together. I'm going to take a short commercial break here and provide some background on Luminex and why this is an important and relevant topic for us. We are a completely mainframe-focused company and are committed to the values of the mainframe ecosystem. This presentation is in partnership with the Share user group, and we've been an active supporter of the community for a very long time. Certainly we have valuable commercial and technology partnerships with co-presenting organizations Confluent and Hitachi Vantara as the parent of Pentaho. So taking a quick look at our mission statement, we are committed to being a trusted advocate, which means we want to sit on the same side of the table as our customers and help identify and solve the critical problems and challenges. And I think the presentation today and our products are in direct support of this goal. I've also highlighted a couple of words, protect, manage, and leverage in this mission statement. And Luminex is well known for our enterprise mainframe virtual tape products that protect and manage mainframe data. But our new MDI products are geared towards helping our customers leverage that data in new and valuable ways. And that's what we're going to spend most of our time talking about today. So with a little bit of deeper background on Luminex, we've actually been delivering products for mainframe data sharing since the 1990s, and frankly, for those who can remember, including bus and tag products that date back into the 1980s. So we've been industry experts in mainframe I/O and connectivity, and in our DNA has been to promote the tools and capabilities and to leverage the technology advancements developed and embraced independently of the mainframe. An example was our DataWare CD product line in the 1990s that delivered CD and DVD recording capabilities for mainframes used for both worm archiving and microfiche replacement, but also high-volume data distribution. And some of these products are actually still in use in data centers today. A few more recent examples, we brought data deduplication to the mainframe in 2006, and our cloud tape product for public cloud archiving was introduced in 2012, before the mainframe community was actively embracing those technologies. So it's given us a chance to have a lot of valuable discussions with our customers about the values and pitfalls of cloud integration, and helped us towards the development of our MDI products that we're promoting today. And for those in the audience that understand the discipline required in mission-critical mainframe operations, and we're rightly hesitant about bleeding-edge technology, Kafka is not brand new, and I've personally been presenting the values of Kafka at Share for over 4 years. So we're excited to bring this to a broader presentation today. So in the next couple of slides, I want to highlight some of the core requirements for access to mainframe data within the enterprise, and then also some of the challenges to meet those requirements. The mainframe is the system of record for much of the organization's most valuable data, and machine log data, SMF, application logs, provide valuable insights to keep the mainframe operating efficiently at the core of the business. So I've often called this big value data as being very distinct from the industry buzzwords of big data that seem to have completely ignored the values of the mainframe. The data needs to be analyzed, and it's often with tools that are developed and deployed off the mainframe. They also need to be analyzed with data sources that are not necessarily mainframe-based. Application developers need access to mainframe data in addition to seamless access to mainframe processing on occasion, and it's generally done in a self-service manner, the way the modern IT development continues. Of course, the mainframe teams have to do all the magic to meet all these demands within the important discipline constraints of mainframe operations, while the management wants to make sure that everything is fast, efficient, with no risk, and it's cheap. So that obviously has some challenges. The mainframe is different. Data formats are different. Application languages can be different. Data access is not necessarily the same as what the non-mainframe analysts and developer communities are familiar with. The goal is to simplify and to make this interaction more seamless. And throughout the mainframe community, we're at different levels of process in making that access more seamless and integrating the mainframe in the broader IT. So one common result is that there are thousands of FTP transfers and accesses every day. So as we look at security, certainly security is paramount across IT. Best practice is to operate with the assumption that the bad guys are already on your network. They know how to use TCP/IP and FTP to access different platforms within the network, and the mainframe's no exception. And we've given complete presentations at Share and other organizations just on this topic, and so we're not going to go too far into that, but the bottom line is using unsecured FTP is a very bad idea, and you're probably doing it. There is a significant hassle and complexity of securing all of this FTP, and it typically causes a spike in the MIPS or CPU usage to make this happen. So when we analyze customer FMF records and try to understand their environments, we generally uncover thousands of FTP transfers that they weren't aware that were happening. They were ad hoc data access, similar to the demands we talked about previously. But also the network traffic itself can often take 10 to 15% of the total mainframe CPU usage, which, depending on how you pay for your mainframe, that can be a pretty big bill. From an efficiency standpoint, it often just isn't practical to manage large amounts of data or big files using TCP/IP. So that gets us to our MDI product line. MDI stands for Mainframe Data Integration. And essentially, we've created a data transfer platform that uses FICON as the network for data I/O. We have data integration control software on the mainframe that identifies the data to be transferred with commands that give instructions on what to do with that data. We have customers moving data to a wide variety of non-mainframe endpoints, and for a wide variety of use cases. And today we want to focus on our Z-Connect product that sends mainframe data to Kafka. The control software has a batch mode, and we'll use this in our example demonstration later. And we also have near real-time streaming implementations that, for example, monitor the JES spool or mainframe log streams and then stream that data down the FICON channel and forward that to Kafka. So of course, FICON channels are designed specifically for the mainframe, and they are widely accepted and used for mainframe production workloads on your DASD, your backups, your HSM, all of your data storage. But FICON is also uniquely capable for data transfer. It is a high-speed block-based I/O. It offloads processing to the channel cards within the mainframe and resulting in negligible CPU use. It's also a very secure protocol. So as we look at some of the challenges to the mainframe access demands, FICON clearly provides a more secure I/O into the mainframe than common TCP/IP and FTP mechanisms. It's not subject to a lot of the network security risks of TCP/IP, and there's a lot of industry expertise that they recommend turning off port 21 and just leveraging FICON for I/O to the most significant extent possible to address these security challenges. Clearly, it's very fast. It's how mainframe data centers move data today. Moving large amounts of data very fast is what it's designed for, which makes it a lot more capable for an integrated mainframe environment. And in our experience and testing, we see that FICON uses about 30 times less CPU than secure FTP, which again can yield some significant cost savings. So by making it practical to not be a data silo and making it practical to access large amounts and frequent amounts of data, the mainframe can be integrated in the rest of the environment instead of being as a silo. So mainframe customers are using MDI products in a variety of ways for offload processing, for moving it to analytics environments. How are they using it specifically with Kafka? And certainly Kafka is an event streaming platform, but we are also seeing some additional values within the mainframe community. There are practical values and as an enterprise data connector, and that's part of the example we're showing today, where the mainframe data sources can be connected to the variety of enterprise applications very seamlessly using Kafka as that connector. And we also see the value of persistent data storage, which offers unique value in ways that traditional message queue systems don't. So one of the comments I found interesting when I talked to an enterprise architect within a large data center is made a comment that within a few years we're more likely to write data to Kafka than we are to files. And that's a real transformative comment about the nature of Kafka and how we view access to data, when we get data, and what the expectations are. With that, I'd like to give Jeff Bean a chance to talk a little bit about Confluent, the company, and Kafka as the technology.
Thanks, everyone. My name is Jeff Bean. I'm a partner solutions architect here with Confluent. I'm responsible for working with our partner ecosystem and helping them and their customers be successful with Kafka. I wanted to spend a little bit of time talking about Apache Kafka for those of you who might be new to the technology. It is a real-time event-based platform in a distributed systems paradigm. So what this means is that you have a Kafka cluster that is divided by topic and by partition. It is a distributed system. It's deployed on a cluster of commodity hardware, either on-prem or in the cloud. And then you have writers or producers of events. And those events are basically little bits of data that go into the topic. And then readers have immediate access to those events in real time. So you can think of an event as a row in a database only happening right now, or a line in a file that you're watching using something like Tail to actually view. Except it's more than that. It's a distributed platform for data streams. What we mean by this is that it has the scalability of a file system. You can achieve hundreds of megabytes per second throughput. You can have many terabytes of storage per server, and you can do this on commodity hardware or in cloud. This basically, you have linear improvement in performance by adding new nodes to the system and capacity as well. But not only does it have the scalability of a file system, it also has the guarantees of a database. You have strict ordering and persistence. So when an event goes into Kafka with a bunch of other events, the ordering of that event is basically set in stone and will never change. So you know that one event happens before or after another. And you can also configure and tune the persistence of data in Kafka. So depending on your particular use case and your particular needs, you can tune Kafka to be either a transient event store where it's a fire and forget, or you can tune it to keep that event data throughout all time. Using a log as an example, if I'm watching a log file using something like Tail, that capability has been around obviously for a long, long time, but being able to reset to any point in the narrative is a big deal. So being able to, as I'm watching this file come in or I'm watching this data come in, being able to stop, pause, rewind, and replay from some specific point in time is a real killer application. And I should note that this is independent of other clients that are also reading from this event stream. So here I have one client doing a rewind and replay while another client is writing to the event stream, but I can also have 3 or 4 other clients playing and consuming this data from different points in the queue. It's a distributed system by design. It's modeled after other distributed systems such as Hadoop. It has replication, fault tolerance, partitioning, and elastic scaling, basically meaning as I add new nodes to a cluster of Apache Kafka, then I get a linear increase in performance and capabilities as well. This underpins a larger shift you may have noticed in our society of this shift to event-driven systems across the industry and across many different industries in the world. We've moved in my lifetime from a static snapshot where I've gotten a daily news report in the newspaper in the garage or in the driveway in the morning to an occasional call from a friend to a constant feed of all the activities from all my friends and a real-time news feed accessible anytime, anywhere from multiple devices simultaneously. This doesn't happen by accident. Underneath technologies like this, you need something to manage every event. So I need a single platform to connect everyone to every event. I need a real-time stream of events, and I need the ability to scroll back through all events for historical purposes. The most successful digital businesses are inherently event-driven. So there are businesses that were born in the cloud and are cloud native, such as Funding Circle and Ticketmaster, which leverage marketplaces serving online customers and reduce development friction to boost machine learning with event streaming so that they can deliver tickets between buyers and sellers. And then you have more traditional ones that are adapting and keeping up with this new world, such as Bosch, which is a manufacturing and construction company to transform their power tools division to an IoT company, right? So you have a power tool that has sensors on it and data generating a stream of events, and you want to be able to do things such as maintain the tool or so on. As well as banks wanting to improve their customer experience through data while staying compliant to regulatory requirements. When you think about the needs for event streaming, it's not really confined to any single organization or industry. The reason so many organizations are leveraging event streaming is because it enables the outcomes to a business will need to deliver in the modern era. Outcomes that legacy technologies simply can't deliver. So for example, in 3 industries, let's look at how they've been transformed by event streaming. In automotive and transportation, If you wanted a car without event streaming, you'd call a car service as a taxi. You wouldn't know if the driver was available. You wouldn't know how much it would cost to get you to your location until the trip was done. And you wouldn't know how long you needed to wait in order to get your ride. But today, with a few clicks, you have a real-time rider-driver match. When you reserve a car, you have a real-time ETA. And you also have a modern connected car outfitted with numerous sensors, so manufacturers have a wealth of diagnostic data that they can turn into customer value. And that data might not only go to a manufacturer or a dealer, but also to maybe a financial services institution that services a loan on that car, or an insurance company which is evaluating the safety of the driver. With banking, without streaming, if you deposited money into an ATM or transferred money via a mobile app, you'd have to wait hours or days to see that reflected in your account balance. Today, we have real-time account updates across the web, mobile, and branch. And then before, fraud checks for things like account login fraud or credit card fraud were all done on a batch basis, given time for money or goods to be stolen. Today, we have real-time fraud alerting. And without event streaming, you all have limited personalization when interacting with your bank. Today, customers are thinking through real-time next best action where they can provide in-the-moment guided journeys, for example, recommending financial products or customer service based on your real-time behavior. And then turning to retail, we as consumers can order a product online, receive a confirmation email, and then one day later get an out-of-stock email because inventory updates are done on a nightly basis rather than in real time. Today, inventory across channels can be managed in real time. Before, we interacted with websites and applications and received a generic experience, and today you can get real-time personalized product recommendations. Netflix estimates this is worth $1 billion a year to their business. And without streaming, it's not uncommon for a major global retailer to have to wait 1 to 2 days to know what they've sold. Today, those reports can be produced in real time. It's clear from these examples that event streaming is a technology that is fundamentally reshaping each and every industry. Right now, there are two models for data infrastructure. First, on the left, you have the ETL, extract, transform, and load data integration model, where organizations move large amounts of data stored to data warehouses, databases, and Hadoop for use in data analytics. This approach allows for high throughput data transfers and is durable, persistent, and ordered. However, it has some major drawbacks. It's a batch transfer, it's expensive, and it's time consuming. Reports are available from this approach well after the data is generated. We often hear about reports being run at the end of the day, and we ask, at the end of what day? The reality is there's no end to the 24/7 business. It's pretty clear that the ETL and data integration model is simply not a fit for running your business in anything close to real time. But the other model commonly known as messaging is meant to deliver data in real time to applications. This model is real time. However, the significant drawbacks it has are around scalability. It's difficult to scale for a high throughput use case. Data is transient and does not persist after consumption, and this is a problem because if something goes wrong, there's no history to replay and fix. So this is the situation you're in. You either have ETL data integration in real time, or you don't. If you want to do messaging in a way that's highly scalable, persistent, and ordered, you can't, and this hinders your ability to innovate. This is where Apache Kafka and event streaming come in. The event streaming takes the best aspects of these two different models that are built for different purposes and builds from the ground up an entirely new and modern technology platform. The platform is scalable, durable, persistent, ordered, and real-time. You can do ETL and data integration in real time, and you can finally do messaging that is scalable and persistent. But event streaming is actually more than real-time ETL and better messaging. Without a company like Confluent underpinning this, it's hard to introduce it to an enterprise with multiple lines of businesses and multiple deployments. In this environment that I'm showing here, you have applications, databases, microservices, data warehouses scattered throughout your organization across multiple lines of business, wanting to coordinate in as close to real time as possible. And worse, if you were to add a new capability to one of these lines of businesses or a new cloud provider or make an acquisition, the amount of spaghetti that you have connecting all these systems actually goes up if you want to extract value from that addition. Confluent has this notion of contextual event-driven applications where I can build things like real-time inventory, real-time fraud detection, real-time customer 360, machine learning models, and real-time data transformation by attaching those existing systems to Apache Kafka and Confluent platform. So whether they're data stores, logs, third-party apps, custom apps and microservices, or mainframes via Luminex, they can be hooked into Apache Kafka, and then value can be extracted into contextual event-driven applications. It's worth noting here that we're not trying to displace any existing system. We are adding value to all the systems in your organization by allowing you to connect clients to Apache Kafka and therefore reduce the amount of effort and work required to maintain the complex real-time interaction between all of these systems. Confluent leverages the deepest Apache Kafka expertise. We were founded by the original creators of Apache Kafka. We've written 80% of the commits to Apache Kafka, and we have over 300,000 hours of experience supporting Kafka. Hundreds of enterprise subscription customers use our products and services, ranging from the Royal Bank of Canada to Bosch to Ticketmaster, Priceline, ING, and so on. In addition to Apache Kafka, we build a platform to round out the total product. Where our enterprise streaming platform was built by the original creators of Apache Kafka, it offers the event streaming capability that I already discussed around Apache Kafka, but adds end-to-end monitoring and analytics, enterprise-grade security, multi-data center replication, stream processing using a SQL-based front end, a cloud-native deployment with our Kubernetes operator, and you can run this as either self-managed software on-prem or just as by swiping your credit card and getting a fully managed service with Confluent Cloud. Quick overview of what this entails. Here you see Apache Kafka color-coded in black at the core of our platform. You can see I'm working from the bottom up. This whole platform can be deployed in a customer self-managed environment, either in a data center or in the public cloud, or you can work with Confluent to just consume and produce data in a fully managed environment with Confluent Cloud. We have on top of our platform KSQL for stream processing, bringing stream processing to the level of the data analyst who knows SQL, so that they can do real-time analytics and aggregation on data. We have an ecosystem of connectors to connect to any data source or sink that might exist in an organization. We have a REST proxy to make Kafka available over HTTP. We have a schema registry for data compatibility so that multiple disparate, disconnected systems can understand the data that each one is consuming and producing. And then we have a series of tools for enterprise operations management and monitoring, such as our replicator for cross-data center replication or on-prem to cloud, such as Auto Data Balancer for making sure that every node in a Kafka cluster is evenly distributed with respect to workload, and our ecosystem of connectors as well as our Kubernetes operator. Rounding this all off, we have a control center for management and monitoring and a series of security features and functions so that we can make sure that, that your deployment of Apache Kafka meets your security standards for your enterprise. So this enables event-driven transformation across industries, whether it's banking and capital markets, retail, healthcare and pharma, travel and leisure, telecommunications, or automotive and transportation. Indeed, Confluent's core mission in life is to put an event streaming architecture at the center of every business. Thank you very much, and with that, I'm going to pass it over to Derek from Pentaho.
Jeff, thank you very much. This is Derek Wilson from Hitachi Vantara, servicing Pentaho. Hey, it's a real privilege to be here, included in this webinar with Luminex and Confluent. You know, Pentaho is happy to be playing this supporting role in demonstrating the power of these great technologies. But before we talk about Pentaho, let's take a moment just to, you know, make sure everybody's familiar with Hitachi Vantara. So Hitachi Vantara is basically the data arm of Hitachi. We were formed early last year. We're leveraging Hitachi's unrivaled combination of 100 years of OT, operational technology experience, and 50 years of IT experience. You know, we're servicing industries across the globe. We're bringing together unique capabilities, skill sets, industry knowledge, technologies to deliver really data-driven solutions to data-driven innovators. That's what Hitachi Vantara is all about. Now, we're providing everything from storage to insight. So we're providing a full range of enterprise-grade technologies that store, enrich, activate, ultimately monetize, unlock the value of your data. These are the solutions and the technologies that we're out there providing every day. So let's talk about Pentaho for a moment. Those of you who are not familiar with Pentaho, Pentaho is a single end-to-end data management and analytics platform. We are source to insights. Pentaho is more than just ETL, right? Pentaho is the only platform delivering the entire data pipeline in a single enterprise-grade experience. We tend to be delivered as glue between a lot of different applications. You know, Pentaho is a metadata-driven metadata-driven engine. We're integrating well into your data architecture and your technology ecosystem. But it is also not just a data management tool, but it is also analytics delivery platform providing both federated data endpoints, you know, for your data scientists and your data engineers, as well as delivering self-service analytic capabilities. Those for your business level data consumers. So let's have a look at some of those. Pentaho contains an entire range of visual and analytics delivery capabilities, from out of the box, operational reporting, analysis, cross-tabbing, dashboards, you know, to a development kit that's also delivering rich, interactive analytics applications. We're serving all your data citizens. You know, the data, we're wanting to make data that is within reach of all your end users while keeping the data locked down in a secure environment, right? That's what you need from an enterprise-grade environment. So we're all about delivering data to the right time and in the right hands. But let's take a moment. Now let's get a better understanding of how all the systems we just discussed, Luminex, Confluent, and Pentaho, let's see how that we can all participate in an enterprise-wide data platform. So I'd like to introduce Daniel Saunders from Luminex. He's created a fraud analysis demo to really illustrate each system's role, how they interact and support each other.
In this demonstration, we're going to show how you can send your valuable mainframe data into your data pipeline. Now, there are several main components to that. You have, of course, your mainframe, which holds that valuable data. And then we have MDI, which is then going to send the data into a Kafka cluster. Let's take a look at the mainframe terminal to see how this process starts. Now, here we have simple JCL, or job control language, for those who are not familiar with the mainframe. This is just a really simple way to set parameters and data inputs and outputs so that you can set what data should flow from your mainframe and into Kafka. Now here you can see we've set our profile as zConnect. That's the Luminex product that sends the data into Kafka. And we've set a few parameters on that, such as the Kafka topic and the conversion that's going to be done on that data. In this case, we have ASCII with Windows line endings, but that conversion can be a wide variety of code pages, or you can just leave it as native if you want the data to stay in its mainframe format. And now once this is set up, all you have to do to send the data is just submit this job. Once the data is submitted, it's going to be sent down the Python channel and onto the MDI box. There, that conversion will take place, and then the data will be passed along to Kafka. To get some more insight on this, let's look at the MDI admin GUI, which is going to show a real-time display of what is happening on MDI. You can see that we're dispatching work, and we're starting the conversion, which means that the data should now be flowing into Kafka. We can open up a simple Kafka consumer and see that indeed data is flowing into Kafka. That data is now available to a wide variety of applications, such as stream processors, microservices, and transformation engines. Now in this case, we have a Pentaho transformation that's open up and running on this data. It's going to take the flag transactions in the mainframe and do some further fraud analysis on them. So you can see that we have the data coming from the Kafka cluster. It's being parsed and then joined with an external database to provide some more analysis about that data. We are then going to be able to do some more fraud analysis on it. And in this case, we're going to be sorting, grouping it by zip code, so we can see by zip code where the most fraud is taking place. And so as you see that the data is being processed, and as it is being outputted, it can then be sent back and consumed by other applications, such as monitoring and reporting tools, or data can be sent to the mainframe. And here, if we just zoom in on one of those reporting tools that we have open, we can see that we indeed have our top 10 zip code report, as well as a few other charts. And so now we've been able to free that mainframe data and get it into Kafka, where it's been able to be analyzed and reported on. So your valuable mainframe data is no longer siloed, but it is now available throughout the entire enterprise.
Thanks, Daniel, for that demo. This is Art Tolsma, and to summarize, the mainframe and its data needs to be fully included and integrated with the rest of an organization's data sources in order to improve business operations and make better business decisions. Kafka makes this possible. MDI makes this practical. And we would love it if you would like to reach out and learn more about any of our companies, products, and technologies and how they work together. We have some of the resources. You can find this information online, and we can open it up for questions and answers.
All right, so our first question, what is Confluent's ongoing relationship with Apache? And please correct me if I said that incorrectly, I'm sorry.
So Confluent continues to commit and contribute to and commit to Apache Kafka in its open source Apache hosted Apache licensed version, in addition to providing additional services and product both on-prem and in cloud to make it enterprise ready.
Great, thank you. And then we have one that says, how does data get back to the mainframe?
This is Art Tolsma. The MDI software on the mainframe has a component, we call it PDQ for pending data queue, and it's essentially a started task listener for responses back to the mainframe. And so from a batch job perspective, we have a bidirectional communication, and so when the commands and instructions are sent to the MDI platform, it actually waits for responses, and ongoing mainframe jobs and activities can wait for positive pass-fail or other feedback responses during that process. And there can be activity initiated from off the mainframe that we can capture, and then integrated with mainframe security, RACF, and others can take those actions. And so there's multiple mechanisms to make sure that it's a enterprise quality bidirectional process.
Great, and our next question here, how different is zConnect from a CDC product?
This is Art Tolsma again. CDC is one of the high-value use cases for identifying the data source on the mainframe, and often it's to create a shadow database off the mainframe, or if you're moving database logs in microseconds to another mainframe for business continuity purposes. And so the zConnect product does not currently have a real-time integration from a direct CDC perspective, but as far as application logs and other near real-time environments, things that are in the log stream, SMF data is a great example. It essentially can leverage the Kafka infrastructure for application endpoints that know how to grab that data and put it in their own visualization tools or add that to their own databases. And so it's a batch and near real-time product, but there are versions of CDC that are real-time that the zConnect product does not support.
And does zConnect run on a general CPU or ZIIP?
zConnect is generally it's on a general CPU, but functionally the activity is on the FICON channel as far as the workload instead of using TCP/IP, and so the CPU usage is significantly less than data transfer products that themselves run on a zip, but the I/O does not. So our experience is it's been extremely low and negligible CPU use compared to everything that it's replacing.
And what is the latency seen on MDI server to convert EBCDIC to ASCII conversion?
Yeah, the EBCDIC to ASCII translation. Yeah, so those happen as part of an inline streaming process. And so as the data comes off the mainframe channel, we grab that data, and as part of our producer sending it to Kafka, we do whatever format conversions are set up in either the command structure or the predefined profiles. And so it happens in lines as part of the streaming process.
And do you have any metrics like messages per second from the mainframe to the Kafka broker? So per second from the mainframe to the Kafka broker.
I don't have any of those metrics. We can do follow-ups. Certainly when there are larger volumes of data, we've got a lot of customer metrics where 10, 20, 50 times faster using FICON channels versus doing any sort of bulk data transfer using IP or other mechanisms. And in some cases where there's data just simply wasn't even feasible to move in their nightly processors or other mechanisms. But as far as the message per second, I don't have that data.
Okay, and one of our attendees is wondering what type of mainframe data can be streamed.
It can be any sort of mainframe data, and we can do various conversions through the MDI process, and then the usefulness is if you know how to use that data on the other end of the Kafka cluster. And so we have a variety of formatting tools, copybook to JSON, and other formatting tools to make that data more readily consumable on the other end. But at some level, there needs to be some understanding on how to use that data. But the data source itself can be anything.
Okay. And how does zConnect handle encryption?
The FICON channel itself is secure, and we have embedded encryption in our I/O stacks and then leverage the Kafka and Confluent security once it's passed off to the Kafka cluster.
And another attendee is wondering, the demo showed what appeared to be a batch job submission to send data. Is there an open lister where a program like CICS can write data messages into which would pass the message data through to Kafka?
Yeah, so we would do that through log files, I'm assuming. Yeah, the demonstration was a batch job, and you can take any data source. Right now from our near real-time streaming, we can pull data sources off of log streams, SMF, or other applications that write their messages to the native mainframe log streams. Or if records or reports are written to JESSpool, those can be pulled off and streamed instantly. So there's a variety of methods. If there are different mainframe native methods to make that easier, we love helping out. So we'd love to hear some extra feedback on things that would be useful.
Thank you. And then can Kafka and Pentaho integration handle large messages, message size greater than 2 megabytes?
Kafka has no problem with large message sizes. I don't think Pentaho does either, but I'll leave it to Derek to round up the answer.
Yeah, so I'll just quick jump in from Derek. We all know it actually some of the values are even more prevalent when the messages are larger and the records are larger, just from leveraging some of the FICON channel. And so with some of the enterprise additions to that Confluent has made with Kafka, that's absolutely a valuable use case.
Yeah, and I apologize. Let me just add, this is Derek Wilson. Yeah, there's no limitation on the Pentaho side.
Great. And our audience is wondering, will there be any sessions like this at Sharon Fort Worth?
Yeah, this is Art. Yeah, absolutely, there will be. Again, I've been mentioning Kafka and some of the values of leveraging mainframe data in the Kafka environments at Share Conference for 4 years now. And as we see this deployed in more customers and environments, we'll have the opportunity to present some more of those detailed use cases. So I'm certainly looking forward to being in Fort Worth and doing this.
And oh, it looks like we may have a couple more here, but we're wondering how we can get a copy of today's presentation. I can actually answer that for you. You can find it online on the Share website. We have one more question here. For real-time use case, we already have Kafka Connect to copy from MQ to Kafka. Is Z-Connect only for non-real-time and batch? There seems to be some overlap in functionality.
Yeah, I would say that there is some overlap in functionality, and I think real-time has been a pretty obvious need and requirement, and so that's been addressed in a few places. But we see a much broader opportunity to move more data sources from the mainframe that are both near real-time and batch into the Kafka environments. And what wasn't considered practical before is something that we've addressed with our MDI product line to make more data sources available in a practical standpoint, which hadn't been necessarily the corporate real-time priorities in the past.
All right, well, those are all of the questions.
I wanted to pipe in real quick on VJ's question around message sizes greater than 2 megabytes. I misspoke a little bit there. There's a limitation on Apache Kafka. Basically, the larger the message gets, the more unwieldy it becomes. When I said there's no limitation, what I basically meant was there are workarounds to this on the Apache Kafka side and on the Confluent platform side, such that it's not really a concern. You can split your messages. You can link to some other store and so on.
Thanks for clarifying for us there. And that concludes today's webcast. Thanks so much and enjoy your day.